So today we're going to be talking about average atomic mass, and an average atomic mass can be found on the periodic table, and it is the decimal number that you find in the box for each element. That number represents a weighted average of all the isotopes of that element. Now, in order to calculate the average atomic mass for an element, you need two pieces of information. You need to know the mass of each isotope that's present, and you also need to know something called the relative abundance for each isotope. The relative abundance is the percentage out of the whole sample that is each isotope. Now, that information is often provided for you, and that's originally coming from lab data. That lab data is usually coming from a mass spectrometer, which works by taking your sample and accelerating it while also deflecting it. Okay. And what happens is the ones that are the heaviest do not deflect very much and don't move a lot, and the ones that are the lightest deflect a lot, and it separates them out. And from that, you can actually generate a graph. And the graph will show you two things. It'll show you the number of different isotopes. In this case, we have one here and one here. So this particular substance has two isotopes. It tells you the relative abundance of those, and it tells you the mass for each isotope. Now, in order to calculate the average atomic mass, we take those two pieces of information and we calculate it like we calculate a weighted average. So we need the decimal abundance and the mass for each isotope. Now, the graph on the previous page was actually for boron, and boron is found in nature as two different isotopes, boron-10 and boron-11. Boron-10 actually has a mass of 10.0129 AMU, and the mass of boron-11 is just over 11. The natural abundance for boron-10 is about 20% of boron-10, and the other 80% is boron-11. And that matches up to the graph that we had on the previous page. Given these information, we can actually calculate the average mass of boron. And to do that, we're going to take the decimal abundance for the first isotope. So our first isotope is the one that is boron-10. We're going to take the decimal for that. So if it's 19.78%, the decimal for that would be 0.1978. I just took that number and I divided it by 100. So that is the decimal abundance, and we're going to times that, multiply that by the mass for that isotope, which is 10.0129 AMU. Now we're going to do the same thing for the other isotope, and then we're going to add them together. So 80.22 is 0.8022%, and then the mass for that was 11.0093 AMU. Now I'm going to reach for my calculator, and the calculator says that it is 10.81, and I'm going to report that with 4 significant figures because there are 4 significant figures in the decimal percentage. Now, if you compare that to the periodic table, it's actually going to be pretty close. And that is average atomic mass.